Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Also, if you find my videos interesting and important to your studies, please don't forget to subscribe. Analyze the frame shown by slope deflection equations. If there is an artificial support at C, then compute the horizontal reaction there. Remove the artificial support, then determine the moment at C. EI is constant. So this problem was one of the problems in the C board exam in the Philippines. And I'll solve this, especially the reaction at the artificial support C, to hold the frame in a situation where there is no side sway. So without this artificial support, this frame will undergo side sway. That's why in the second part, we have to remove the artificial support and determine the moment at C. So because of the presence of this artificial support, side sway is prevented, and therefore it is a non-sway frame. So we now establish moment equation. So MAB equals 2EI, 2 times 1, assume EI equals 1 over L, 5, quantity 2 theta 0, 2 times 0 plus theta B minus 3 times 0 because there's no side sway. So MAB therefore is equal to 0.4 of theta B, equation 1. Likewise, MBA, so it is theta B that is doubled, so we double this, so MBA is equal to 0.8 of theta B, equation 2. Then for MBC, we expect moments at B and C. So 2 times EI 1 over L 5, quantity 2 theta B plus theta C minus 3 times 0 minus fixed moment 16 times 4 times 1 square over 5 square. Simplifying, MBC is equal to 0.8 theta B plus 0.4 theta C, then minus 2.56. Call that equation 3. Then next is MCB. We interchange coefficient. Then the fixed moment is positive. So plus 16, 4 square, 1 over 5 square. 4 square times 1 over 5 square. Simplifying, MCB is equal to 0.4 theta B plus 0.8 theta C plus 10.24. Call that equation 4. Then MCD is equal to 2 times 1 over 5, quantity 2 theta C plus 0 minus 3 times 0. There's no fixed moment, there's no load. So MCD is 0.8 theta C. Call that equation 5. Then MDC is 2 times 0, so we make this half. MDC equals 0.4 theta C. Equation 6. Equilibrium at B, MBA plus MBC equals 0. So MBA 0.8 theta B plus 0.8 theta B plus 0.4 theta C minus 2.56 equals 0. So 1.6 theta B plus 0.4 theta C equals 2.56. We call that equation A. Then at C, MCB plus MCD equals 0. MCB is 0.4 of theta B plus 0.8 theta C plus 10.24 plus MCD, it is 0.8 theta C equals 0. So combining like terms, 0.4 theta B plus 1.6 theta C equals negative 10.24. So solving equations A and B simultaneously, we get theta B equals 256 over 75 EI, and theta C is negative 544 over 75 EI. From here, we can compute MAB and MBA, MDC and MCD necessary in computing for the horizontal reactions at A and D to determine the reaction at the artificial support. MAB is zero point 0.4 of theta B, so 1.3653 kilonewton meter. MBA is zero point 0.8 theta B, or times 2 of this moment. So we have 2.7307 kilonewton meter. MCD is 0.8 theta C, so negative 5.8027 kilonewton meter. MDC is zero point 0.4 of theta C, or half of that value. So negative 2.9013 kilonewton meter. So having found, let's have the moments transferred. So since MAB is positive, so it's clockwise. BA is also positive, it's clockwise. So to solve for AX prime, we draw free body diagram, imagine, for AB, and we sum up moment about B equal to 0. Same is true with D. So since MDC is negative, so it is counterclockwise in the figure, counterclockwise also for MCD. So summation moment B equals 0, AX prime times 5 equals MAB plus MBA. So AX prime can now be computed, and it is rightward, 0.812 kilonewton rightward. Likewise, summation moment C, so dx prime times 5 equals mdc plus mcd, which are now treated positive because they are in the correct uh, directions. So dx prime is equal to 1.7408 kilonewtons meter leftward, so that we can now compute the reaction at the right support. R sub c plus ax prime equals dx prime. So R sub c plus 0.8192 equals dx prime 1.7408. So therefore, the horizontal reaction on the artificial support is equal to 0.9216 kilonewtons, and that is rightward. So let's have the second part. We remove the artificial support, and then let's find the moment at C. So because of the removal of the artificial support, this frame will undergo side sway, and let's assume it is in that direction. So MAB will now be 2 times 1 over 5, quantity 2 times 0 plus theta B minus 3 times delta over 5. So there is now side sway for these two columns. So simplifying, MAB equals 0 0.4 theta B minus 6 over 25 of delta. Call that equation 7. Then MBA is, we double this, 0 0.8 of theta B, then minus 6 over 25 of delta, equation 8. MBC, there's no side sway for this horizontal frame member. So 2 times 1 over 5, quantity 2 theta B plus theta C minus 3 times 0, then minus 16 times 4, 1 square over 5 square, fixed moment. Simplifying, MBC is 0 0.8 theta B plus 0 0.4 theta C minus 2.56, equation 9. MCB interchange, then plus 16, 4 square, 1 over 5 square for the fixed moment. So MCB is equal to 0.4 of theta B plus 0.8 theta C plus 10.24. So call that equation 10. Then MCD is 2 times 1 over 5, quantity 2 theta c plus 0 theta d, then minus 3 times delta over 5. Simplifying, MCD is 0.8 theta c, then minus 6 over 25 delta, equation 11. Finally, NDC interchange, so it is this that is double, but this is 0, so this becomes 0.4. MDC is 0.4 theta c minus 6 over 25 of delta, equation 12. Then apply equilibrium at B, MBA plus MBC equals 0, so 0.8 theta B minus 6 over 25 delta plus 0.8 theta B plus 0.4 theta C minus 2.56 equals 0. So 1.6 theta B plus 0.4 theta C minus 6 over 25 delta equals 2.56. So call that equation C. Then equilibrium equation at C, MCB plus MCD equals 0. So MCB is 0.4 theta B plus theta C plus 10.24 plus MCD 0.8 theta C minus 6 over 25 delta equals 0. Simplifying, 0.8 of theta B plus 1.6 theta C minus 6 over 25 delta equals negative 10.24, equation B. Then we must have our third equation, and that is based on statics. AX plus BX must be equal to 0. So these are the reactions at A, and moment AB is assumed to be clockwise as well as at BC. And at CD. So that if we isolate AB and we sum up moment about B, AX equals MAB plus MBC. AX times 5. So AX plus DX equals 0. Summation versus X equals 0 for the entire system. And AX times 5 equals MAB plus MBA. If we isolate this as a free body for column and we sum up moments about B. So AX therefore is 1/5 of quantity MAB, which is 0.4 theta B minus 6 over 25 delta plus MBA 0.8 theta B minus 6 over 25 delta. Simplifying, AX is equal to 0.24 theta B minus 0.096 delta. Then likewise, summation moment about C equals 0. Imagine this is isolated as a free body. So dx times 5 equals mdc plus mcd. So dx is 1/5 of mdc, which is 0.4 theta c minus 6 over 25 delta. Then plus mcd 0.8 theta c minus 6 over 25 delta. Simplifying, dx is equal to 0.24 of theta c minus 0.096 of delta. Substitute into this equation. So ax 0.24 theta b minus 0.096 delta plus dx 0.24 theta c minus 0.096 delta equals 0. Simplifying, so we have 0.24 theta b plus 0.24 theta c minus 0.192 delta equals 0. So solving these three equations, C, D, and E simultaneously, we obtain theta B equals 272 over 105 EI. Theta C is equal to negative 848 over 105 EI. And delta is equal to negative 48 over 7 EI. Because delta is negative, so sideway is leftward. But let's just compute moment at C, which is required, and that is moment in CD. So moment C equals 0.8 of theta C then minus 6 over 25 of delta, which is negative 48 over 7. So moment at C, moment CD is equal to negative 4.815 kilonewton meter. So that's it for this uh, problem.